Hey there, we are now on to section 5.7, geometric proportions. Essential questions for today: what proportions can be made by parallel lines in a triangle? And also, what proportions can be made by several parallel lines cut by a transversal? Note card 171 is called the side splitter theorem. We've got a triangle and we split the side with a line that is parallel to the base, okay, or parallel to one of the sides of the triangle. When that happens, it splits the two respective sides of the triangle in proportion. So we know no matter where it splits it, but we know that A is to B as C is to D. And that's what this is right here. When I say is to, A is to B, that's a ratio, and you can write it as a fraction. So A over B is going to equal C over D. Another thing I wanted you to know is you can be creative with this, and you can also set it up different ways. Like right here, you could say A is to C as B is to D, and that's just something that I put right here in addition so that you can see there's other ways to set them up. But most typically, when you see work done for these, you're going to see them go along the side. So again, A is to B as C is to D. Pause me and finish up note card 171. Now we're moving on to note card 172, side splitter theorem examples. So if you look here, we've got parallel lines, the little arrows there, and they're supposed to be here on this one as well, but let's just focus on this one right now. So we know we've got a side splitter, and we know that it cuts these sides in proportion. So 5 is to 3, as 4 is to question mark. I'll call that question mark X. And then you just cross multiply. So you say 5 times X equals 4 times 3. So that's 5x equals 12, and you divide both sides by 5, you get x is 2.4. Yes, I want you to draw this triangle and write this work out. I have another example for this note card. If it'll fit on the same side, great. If you need to go to the back, that's fine too. So we've got this. You don't see the arrows, but you are told right here that FE is parallel to GD, okay? So FE is parallel to GD, and we have got GF is 45, CD is 10, and CG is 9. And we want the length of all of CE, okay? So over here on this example, we just wanted EC, okay? But on this one, we want the length of all of EC. So I'm going to do the work on the next slide. Here's the same picture, the same problem. All right. So we want all of this. I'm going to uncover this, and this is where it's labeled. When we want this whole length, we're going to call that X, and that means we need to find out the whole length of this side. So we just do 45 plus 9 and get 54. Now, like I said earlier, when I was showing you note card 171, you can be creative with this as long as you're being intuitive, okay? So what you can do is you can say all of 54 is to 9 as all of X is to 10, and we can solve. Now, why didn't I do all of 54 is to 45? Because I don't know this one down here, and I don't need it. Okay, so you need to use what you're given and what you need to find. Now, all of X is to 10, as all of 54 is to 9. So there's the setup. Now, of course, I could have put 54 over 9 on the left and X over 10 on the right. Then you cross multiply. You get 9x equals 540. Divide both sides by 9. You get that X is 60. Okay, so that is 60. Pause me and finish up note card 172. All right, note card 173. Parallel lines cut by transversals. We've talked about this, but what if we have 3 parallel lines cut by 2 different transversals? And so I want you to draw this picture, and I want you to label these lines K, M, and N. This line is P, this line is R, and these little segment links right here, 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 and here are A, B, C, and D respectively. And then over here it just says that K, M, N, P, and R are labels for lines, and A, B, C, and D are lengths of segments. So go ahead and get this stuff copied down, and I'm going to talk more about it in the next video.